So a pleasant day to everyone. I am Lady Neri, your reporter for today's video. So I will be tackling the topic IP addressing and subnetting. So have you ever wondered what handles the connection between devices that send and receive information across a network? The address of the interface in which both the host and a router send and receive IP datagrams is called the Internet Protocol or IP address. So, let us dig deeper to our discussion to better understand the basic concepts of IP addressing and subnetting and their significance in the technological world. When IP was first standardized in September 1981, the specification required that each system attached to an IP-based internet be assigned a unique 32-bit internet address value. One of the fundamental features of classical IP addressing is that each address contains a self-encoding key that identifies the dividing point between the network prefix and the host number. So an IP address is also a device for use on large networks, have a hierarchical structure and do provide logical groupings, and identifies both a network and a host. So the IP address, which has a hierarchical structure, do provide logical groupings, and identifies both a network and a host, is device for use on large network. To make internet addresses easier for people to read and write, IP addresses are often expressed as 4 decimal numbers, each separated by a dot. This format is called dotted decimal notation. So the dotted decimal notation divides the 32-bit internet addresses into 4 8-bit fields and specifies the value of each field independently as a decimal number with the fields separated by dots. The IP address has two basic parts, namely the network part and host part. The first part of the IP specifies who or where the IP address is from. This is the network identifier. And the second part specifies which host or machine or node it is from. This is the host identifier. IP address works in an IP network like a postal address. For example, a postal address combines two addresses, address or your area, your house address. The address or your area is a group address of all houses that belong to a specific area. The house address is the unique address of your homes in that area. Here, your area is represented by a PIN code number. In this example, the network address comprises all hosts which belong to a specific network. The host address is the unique address of a particular host in that network. So in this connection, classical addressing is a network addressing. The Internet's architecture from 1981 till classless inter-domain routing was introduced in 1993. This addressing method divides the IP address into 5 separate classes based on 4 address bits. So now let us know the 6 IP classes. Let's start with class A. This IP address class is used when there are many hosts. In a class A type of network, the first 8 bits, or also called the first octet, identify the network, and the remaining have 24 bits for the host into that network. An example of a Class A address is 102.168.212.226. Here, 102 helps you identify the network and 168.212.226 identify the host. Class A addresses 127.0.0.0 to 127.255.255.255 that cannot be used and is reserved for loopback and diagnostic functions. So let's move on to Class B. In a B-class IP address, the binary addresses starts with 10. In this IP address, the class decimal number that can be between 128 to 191. The number 127 is reserved for loopback, which is used for internal testing on the local machine. The first 16 bits, or known as 2 octets, help you to identify the network. The other remaining 16 bits indicate the host within the network, and an example of Class B IP address is 168.212.226.204, where 168.212 identifies the network and the 226.204 helps to identify the hot network host. So next is the Class C network. Class C is a type of IP address that is used for small network. In this class, 3 octets are used to indent the network. This IP ranges between 192 to 223. In this type of network addressing method, the first 2 bits are set to be 1, and the third bit is set to 0, which makes the first 24 bits of the address for them, and the remaining bit as the host address. Mostly, local area network use Class C IP address to connect with the network. For a Class C IP address, 192.168.178.1. So next is the Class D network. Class D addresses are only used for multicasting applications. Class D is never used for regular networking operations. This class addresses the first 3 bits set to 1 and their 4th bit set to use for 0. Class D addresses are 32-bit network addresses. All the values within the range are used to identify multicast groups uniquely. Therefore, there is no requirement to extract the host address from the IP address. So Class D does not have any subnet mask. Example for a Class D IP address: 227.21.6.173. So let's move on to Class E network. Class E IP address is defined by including the starting 4 network address bits as 1, which allows you to incorporate addresses from 240.0.0.0 to 255 to 255.255.255. However, E-class is reserved, and its usage is never defined. Therefore, many network implementations discard these addresses as undefined or illegal. Example for a Class E IP address is 243.164.89.28. 85. RFC 950 defined a standard procedure to support the subnetting or division of a single Class A, B, or C network number into smaller pieces. Subnetting was introduced to overcome some of the problems that parts of the internet were beginning to experience with the classful two-level addressing hierarchy, such as first, internet routing tables were beginning to grow, and second, local administrators had to request another network number from the internet before a new network could be installed in their site. Both problems were attacked by adding another level of hierarchy to the IP addressing structure. Instead of the classful two-level hierarchy, subnetting supports a three-level hierarchy. So subnetting attacked the expanding routing table problem by ensuring that the subnet structure of a network is never visible outside of the organization's private network. The route from the internet to any subnet of a given IP address is the same, no matter which subnet the destination host is on. This is because all subnets of a given network number use the same network prefix but different subnet numbers. The routers within the private organization need to differentiate between the individual subnets, but as far as the internet routers are concerned, all the subnets in the organizations are collected into a single routing table entry. This allows the local administrators to introduce arbitrary complexity into the private network without affecting the size of the internet's routing tables. Subnetting allows you to create multiple logical networks that exist within a single class A, B, or C network. If you do not subnet, you are only able to use one network from your class A, B, or C network, which is unrealistic. So subnetting attacked the expanding routing